Rui, and today's video is on acid rain.
So hello everyone, today we'll talk about acid rain. Now regular rainfall is already somewhat acidic. You might ask yourself, why is that? Well, it has to do with this reaction here between carbon dioxide and water. When bubbled carbon dioxide gas is dissolved in water, you get carbonic acid, which as you know is a weak acid and decomposes, forming the bicarbonate ion here as shown. This is a naturally occurring process, and because of it, the pH of rainfall can be as low as maybe 5.6 naturally, although it's typically more like pH 6, depending of course on where you are and season and various other atmospheric factors. But certainly rainfall is naturally somewhat acidic. You might recall that nonmetal oxides create acids in solution, and a couple of the ones that spring to mind and are germane to our conversation about acid rain are these two here, sulfur dioxide, which when you add it to water here forms sulfurous acid, the weak acid, and the bisulfite ion, and also nitrogen dioxide here, which when you add it to water forms nitric acid, and nitrous acid. So nitric acid, as you remember, is a strong acid. This one dissociates strongly, and nitrous acid is a weak acid and dissociates weakly, but in any case, both are acids. So the sulfur dioxide problem can get a little bit worse. If you get sulfur dioxide and react it with oxygen, as shown here, you can form the sulfur trioxide molecules. Okay, you can get sulfur dioxide and react it with ozone and form the sulfur trioxide and oxygen. Well, that's also okay, but not so okay, because what happens here when the sulfur trioxide and water meet, you make sulfuric acid, H2SO4. Now that's a strong acid, and that can be formed in the atmosphere. So consequently, we'll have a quick summary of the acid rain reactions here. And that is that the nitrogen oxides NOx, X for various subscripts, form nitric and nitrous acids in the atmosphere, and the sulfur dioxide forms both sulfurous and sulfuric acid in the atmosphere. All of this here is related to human activities, although there are some natural sources of nitrogen oxides and sulfur oxides in the atmosphere. So let's look now at the process of acid rain and pollutant dispersal. The acid rain is caused by pollution and by natural causes, of course. And as those particles and gases are emitted, they are carried by the wind and rain down in other areas. Consequences of acid rain. Now, acid rain, we said, is rain whose pH is less than 5.3. So they can obviously damage rivers, streams, lakes, and other terrestrial habitats as well. Here are some examples. These forests are damaged by acid rain, and some losses of grasslands and croplands, as you can see. Of course, there are also losses to human food production, and these losses can be cumulative. In other words, continued acid rain can damage soil's ability to grow crops. So acid rain is also damaging to human systems like architecture and infrastructure. Of course, antiquities such as sculptures and ancient architecture are also damaged by these, particularly if they're made of limestone or marble. And of course, buildings and roads, etc., that are made of concrete are also at risk from acid rain. Fortunately, there is some hope, and not all is lost with acid rain. First of all, a good reason is that the natural world has some resistance in the form of solid bases, which are marble and limestone. And let's look at limestone particularly. Calcium carbonate makes limestone, and that carbonate ion acts as a base and can absorb those free protons and make the bicarbonate ion. So there's some resistance. Also, humans are getting better at controlling pollution. For instance, we have catalytic converters in automotive applications and in some industrial settings. And also, industrial design itself is improving. So that is to say, if you have point source pollution, it can be dealt with at source. And that's actually a little bit better than having pollution going all over the place and trying to catch up mobile sources such as motor vehicles. We're also having fewer combustion-based vehicles and combustion-based energy generation, although the trend towards burning coal is troubling in this regard. Anyway, that's a quick introduction to the topic, some of the problems, how acid rain is caused, and some hope in the form of solutions in the future. So thanks everyone, and we sure do hope to see you soon. And I would really invite you to have a look at the next two videos in our playlist. Do have a look, and stay tuned for our next lesson, the beginning of our next unit in Chemistry 12, the Introduction to Electrochemistry.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe!